welcome to our channel Way to Know. So in this video we'll explain a model which is basically used to predict a temperature. So what we are basically doing is we have taken a set of temperature values, and then based on those temperature values we wanted to predict the next temperature that's going to come. So that means predicting a temperature value based on past readings. So this particular model is basically using a time series prediction model, which actually is a very simple model, and as usual we'll be using the tensorflow. Okay, so the steps here are, we are going to take the data, and then we are going to arrange it in a form such that we have a sliding window format. So what we are doing is we are using different sequences of data, and then we are putting it into an array. And here we are using a simple regression model which has only just one layer. Okay, so this particular layer is a very simple neural network, and this particularly is a linear regression model which uses, like example, you can say y is equal to mx plus c, right? Kind of weights and biases are used here, and then once this is done, we are slightly optimizing using the Adam optimizer, and we are optimizing the loss as well by using the mean square error. Okay, and we have taken a very low count for now. So, and we are trying to normalize the gradients here. Okay, and we are also testing, and then we are saving the model using keros. Okay, so saving the model to .keros as well as .tflight. So once you do that, actually we have to see the models here. Okay, .tflight will be seen. Okay, and you have to download that. So the simple thing is you have created a model, trained it here. We are actually using Google Colab, and then we are creating a .tflight model. Okay, and then this tflight model, okay, is actually used to convert it into a .h model. So you see here we have a temperature data in Excel, and then we have a .tflight file which is downloaded from the Colab, and that is being converted into .h using the Windows command. Okay, and then we are actually porting the code to Arduino Nano 33BLE. This is the Arduino file, and the .h file, this has the model. Okay, so this is the file, Arduino file, simple file. Okay, which is again here Arduino has inbuilt libraries for TensorFlow. You can use that. A model is loaded first. Okay, and then we are actually trying to interpret the data by giving random values, and we tried different things here. So one thing is we just gave a single temperature value, like example 28 degrees or something, and then like bunch of 25 values which are just 28 degrees, and the model predicted the output as 28 because it should come as 28, right? And that means we trained the model on only single value, but here while working on the board we gave random values to see how it behaves. So we have seen that as the model is not trained, it was giving random values, but when 28 was given, we were exactly getting the output. So here we are inputting the data, running the reference, and then fetching the data and just printing. Okay, and whatever we printed, we are just tried to convert it into a PWM signal to blink an LED according to the value that we have received. So 4 steps here, right? First, collect the data. So for collecting the data, what we did is we interfaced DHT11 to the Arduino Nano board, Arduino Nano BLE33, and then we actually collected the data. You had the linear regression model, and then trained the model, generated the .tf light and converted into a .h to be used with Arduino, and then we have the Arduino code which actually is pulling the model, taking the data, performing the inference, and giving the output. So the sequence of steps are followed, and we have seen that the model is working fine. This is a very simple model, kind of hello world model which we talk about, sine wave, right? It's that kind of model, and you can experiment it very easily even if you are a novice. So few things are auto generated, might be you just need to know what is happening, but you use them because developing from scratch is not a easy thing here. Just a glimpse of what is done. Thanks for watching.